So as you see in the code here, we have defined a global variable called sum. This sum will be used for updating the greater sum value at every single level and in every single node. And as you see the first line starts by saying transform to the util of root.type. This basically means that the function keeps traversing to the rightmost node, and when it comes to the rightmost node, it replaces the rightmost node by 0. Why we need to do this here is we have to basically take the rightmost node sum and store it in sum, a rightmost node value and store it in sum, and this will be updated accordingly. So that is why we go to the rightmost node using the above recursive line, and after the control passes from the above recursive line, we keep updating the sum. So if you take the rightmost node value, that value will be updated with sum, and that sum will be subtracted from the root.data value. So the rightmost node value will automatically become 0, and similarly the control will immediately pass to the left subtree. Why this passes to the left subtree is the sum of all the nodes from the rightmost subtree and the root node should pass to the left hand subtree. The left hand subtree will again pass the control to the right subtree, which will update its value accordingly. This is how it keeps updating. So the basic intuition lies in the first line, which traverses to the rightmost subtree, and once it keeps traversing to the rightmost subtree, it keeps collecting the sum values accordingly and changes the root.data values accordingly. And after it changes the root.data values accordingly, the changed sum value is passed to the left subtree, which again passes it to its corresponding right subtree. So this is how this program keeps happening. So we saw the code earlier, and let's take an example to get the intuition of the code clear. So we'll have this binary tree and convert this binary tree to a greater sum tree. So the example here starts from the root node 12, and as you see in the code, the control of the program shifts from 12 to 19, which is given in the first line. So 12 to 19. At 19, the code goes from 19 to 20. At 20, this is the base case. The code goes from 20 to the right subtree of 20, which is non-existent. So it returns a null value to 20. So let's see what's going to happen at 20. At 20, the sum value is going to be sum is equal to sum plus root.data. So sum plus root.data. Root.data is 20 and sum is 0. So sum is going to be 20, and root.data is going to become, root.data here is 20. That's going to be sum minus root.data, which is 20. Sum is 20 minus root.data, which is also 20. So root.data is 0. What this means is there is no node in the binary subtree that's greater than the value 20. So the value of 20 is automatically going to be 0. And now the control passes to the left subtree of 20, and since that's non-existent, the control reverts back to 20. So after going back to 20, the control goes back to 19. So at 19, let's see what's going to happen. You have only one value that's greater than 19, which is 20. So the sum is going to be, sum is equal to 20 plus 19, which is 39, and root.data, which is the value at 19, is going to be modified as 20, which is 39 minus 19, which is 39 is sum and 19 is the existing root.data value, which is 19. Now root.data becomes 20. The control now goes to the left subtree of 19, which is at 14. So at 14, the control goes to the right subtree of 14, which is at 17. At 17, it further goes to the right subtree of 17, which is null, and it returns a null value. So let's see what's happening at 17. At 17, the sum has to be 20 plus 19, since there are only two nodes which are greater than 17. So the sum value is going to be, sum is already 39 plus 17, which is 56, and the root.data, which is 17, is going to change as root.data is equal to sum minus root.data, which is 56 minus the existing root.data value, which is 17, and it becomes 39. Since it becomes 39, we get an idea that there are only two nodes, 19 and 20, which are greater than 17, and the sum of those two nodes become the value of is replacing the value of 17. The control now goes to the left subtree of 17. So that is non-existent, so it returns a null value. The control again goes back to 14. So let's see what's happening at 14. At 14, there are say 1, 2, 3, 3 values which are greater than 14. So the sum has to be 56 plus 14, which is equal to 17. And root dot data represents the value at the node which contains the value 14. That has to become sum 70 minus root dot data, the existing root dot data value, which is 14, which is 56. So we get this idea that there are 3 nodes, 17, 19 and 20, which are bigger than 14. So the value at this node becomes 56. The control again goes to the left subtree of 14, which is 12.9. It again goes to the right subtree of 12.9, which is non-existent, and it returns a null value. At 12.9, we have 4 value, which is 82.9. And root dot data, which is the node containing the value 12.9, becomes 82.9 minus 12, which is nothing but 70. The 70 represents the value of all the 4 nodes, 17, 14, 19 and 20. If you add all these 4 nodes, you get the value 70. And the control now goes back to the left hand subtree of 12.9, which is non-existent, so it returns a null value. Then the control goes back to 14. At 14, the control goes back to 19. Control goes back to 14. 14 returns the control back to 19. So the control goes from 14, then 14 to 19, and after going back to 19, it goes back to 12. This is simply a recursion that's happening within the binary subtree. Because 14 has been replaced by all the nodes which are greater than it, 19 has been replaced by 20. Similarly, 12.9 has also been replaced by 70. Now what's remaining to be replaced are 12 and 11. So at 12, let's see what's going to happen. And the control actually goes back to goes from 19 to 12. So at 12, then the control now goes to 12. At 12, let's see what's going to happen. We have 4, 1, 2, 3, 4, 5 values, which are 12.9, 14, 17, 19 and 20, which are greater than 12. So the value of sum has to be, sum is equal to sum plus root dot data, which is 82.9 plus 12, which is 94.9. And the root dot data, which is 12, has to be replaced by, it's 94.9. Your data is 94.9 minus 12, which is 82.9. So that value at the root node is also replaced by 82.9. Now what's going to happen here is control will go back to the left hand subtree of 12, which is 11. So control from 12 to 11. At 11, the control goes to the right subtree of 11, which is non-existent, so you get a null value. So at 11, let's see what's going to happen. Sum is going to be 94.9 plus 11, which is 105.9, and the root value is replaced by 105.9 minus 11, which is 94.9. So the value at node 11 is replaced by 94.9, and the control goes to the left subtree of 11, which is again non-existent, and the control goes back to 11, which gives the control back to 12, which ends the program. So if you see here, the values which make the greater subtree are 0, 20, 39, 56, 70, 82.9 and 94.9. So I'll try to draw the greater subtree here. So 94.9 replaces 11. So this is 94.9, and this is 82.9. And what is being replaced at 19 is 20. What is replaced at 20 is 0. What is replaced at 14 is 56. What is replaced at 17 is 39. What is replaced at 12.9 will be 70. So this is the greater subtree. which has been obtained you are using the above greater sum tree, using the above binary sum tree. So I hope you got this concept clear. Thank you.